This video is on ketones. Ketones are pretty similar to aldehydes, where it has a carbonyl group plus two single bonds to R groups. So an aldehyde, if you recall, had a bond to an R group, but then it had a bond to an H group. So the only difference between these two is we're replacing an H with an R. So here are some examples of ketones for you, where you have your O double bond C with your two R groups. And you'll see that's the same every time. So acetone is a very simple ketone. Acetone is used as a cleaning solvent. You'll use that in the lab if you're doing dishes for different pieces of glassware. And here is your carbonyl carbon and oxygen. Here are ketones found in nature and in pharmaceuticals. So you have codeine and hydrocodone. You have opiates here, painkillers. You'll notice you do have alcohols. Here's an alcohol in codeine. And here, if you change codeine over to hydrocodone, this is where it becomes a ketone here. You have an O double bond to your carbon and your two R groups here. Notice here you have your OH. So that's why that one is not a ketone. That's your alcohol. Here's prednisone. This is used for asthma. If you have asthma or allergic reactions to things, you might have used prednisone before. Your ketones, looks like we have three different ketones here. Here's our carbonyl group. Here are our R's, carbonyl with an R, and then carbonyl with an R again. So here's a sugar, fructose, and here's your ketone. Again, there's your R and your R. How do we name ketones? We're going to drop that E like we did with other things, and this time we're going to add a known on the end of it. You're still going to find the longest chain. That will be your parent chain, and use the prefix accordingly with a meth or an eth or a prop or a but, etc. Your locator number begins at the carbonyl carbon, so that will be number 1. And then if you have substituents on that parent chain, you'll use locator numbers for that. So if we look at an example here, there's your carbonyl carbon, and this looks like it has 6 carbons attached to it. And we're changing the ending to ONE. And we put a 2 here because that is where the carbonyl carbon is located. Over here, the carbonyl carbon is on the 3rd, so we put a 3. Still has 6 carbons total. If we have branched, so again, your main chain here looks like it is 7 carbons, so that's why we have the heptanone. And the double bond O is off the 3rd carbon, so we have a 3 here. And then we have an ethyl and a methyl group. The alphabet does take precedent, so that's why we have the 5-ethyl before the 2-methyl. Okay, here is D-sorbose, a simple sugar. Highlight and label all of the functional groups in this model. So I am just starting on the left. If I see an OH not attached to a cyclic ring, I am most likely thinking alcohol. So here, and here, and here, and here, and here, those 5, 1, 2, 3, 4, 5, they are alcohols. So I'm going to say red equals alcohol. This is a secondary alcohol. No, I'm sorry, this is a primary alcohol, because my C is only bonded to one R group. This is a secondary alcohol because it's bonded to two R groups. This is a secondary alcohol. This would be a primary alcohol. And this would be a secondary alcohol. So the only other functional group we have here would be this O double bond C to two R groups, and that is the definition of a ketone. So if I erase this just to show the ketone a little clearer, this C is bonded to an R group here and an R group here. And we know that's exactly what a ketone is. Provide a skeletal line structure for the branch-chain ketones with the following IUPAC names. Include non-bonding electrons. Okay, so I would encourage you to pause the video and try this on your own. So we have 2-methyl-3-octanone. So right here tells me that it's an 8-membered ring. So I'm going to draw that a while. So that should be 8. 1, 2, 3, 4, 5, 6, 7. That is 8. 3-octanone tells me that off of the third carbon, I have my double bond O. So 1, 2, 3. So this is where my double bond O will go. And then 2-methyl just tells me off of the second carbon, I have a methyl group. So that's just going to be a line straight down like that. And that is that compound. The next one, I'm going to do this one down here. 3-methyl-2-octanone. Again, octanone tells me that there are 8. So 1, 2, 3, 4, 5, 6, 7, 8. And the 2 tells me that off the second carbon, if we're starting here, that will be my double bond O. And off the third carbon will be a methyl group, straight down. Just notice from earlier, if the peak is down, you draw the substituent down. So that's why we drew that down here. Notice we didn't draw it up from there. And the last one, we have the ending is hexanone. So we have a 6-membered chain. So it should look something like that. And off of the third, we'll call this the third, there's a double bond to oxygen. Then we have a 2,2-dimethyl. So off the second carbon, which we'll say is there, we have 2 methyl groups. So 1, 2. And off the fourth, which we will say is here, we have an ethyl group. So there's our ethyl group. And then there's our main chain. So that is the compound for that.